Hello. In this video, we will introduce conic sections and begin with reviewing one of our most special conic sections called the circle. Let's get started. So to define conic sections, let's begin by visualizing something that almost resembles an hourglass, where we have two cones stacked on top of each other. In this situation, if we were to slice this cone using a plane at various angles, it turns out that we would create what we call a cross-section on that plane, and it would have different types of shapes. The first shape that you see in this picture below is the circle. We notice that the circle happens when our plane slices through one of the cones parallel to the base. So we'll talk about that circle in just a moment. The other ones that you'll notice are a degenerate circle when we slice at an angle that looks like an ellipse, and finally in the middle the parabola, and on the right the hyperbolas. So in our future videos we'll be discussing each of those. But let's get started with the circle. So what do we mean by a circle? I'm sure you've drawn a circle and you've seen a circle in your life, but the formal mathematical definition of a circle is the set of all points which are exactly the same distance from a fixed point in the center, which is called the center. Now that distance has a name as well called the radius. And typically we use lowercase r to define the radius and uppercase C for center. Now the center will have an ordered pair, a location, and its x value is known as h, and its y value is known as k typically. So if we start off with a circle who's centered at a point hk, how could we represent an equation that models any point on that circle? Well, that is actually discovered by using the Pythagorean theorem. If you look at our circle that's on our slide here, notice that if you took the center point and actually picked any point on the circle called xy, if you then constructed a right triangle, you could use your Pythagorean theorem or the distance formula to come up with this equation for r, which would be the square root of the distance between those 2 points. In general, we usually write it in terms of r squared. X minus h squared plus y minus k squared should always equal r squared. And check that out yourself with your distance formula or your Pythagorean theorem. Now with that in mind, that should be familiar to you from previous classes. With that in mind, let's remember how we could use the formula when given information about the circle. In this example, it says, what if we had a circle whose radius was 5 and whose center was at 3, -5? What would our circle's equation be? Well, if you remember here that our h value and our k value go into this equation with the opposite signs that we are given. So we would have, for example, see if you can do it yourself, x minus 3 squared plus y, notice it's plus 5, that's right, squared, and our radius was 5, so our radius squared would be 25, wouldn't it? Now this would be what we call the equation of this circle in the standard form. And what we're going to be talking about in this chapter, in this series of videos on conic sections, the next 3 videos after this, will always be how do we write the equation in standard form, and then how do we graph that conic section. So first of all, we have it in standard form, and then we would be able to graph it using the center and the radius. Feel free to check out the Desmos link on that slide to go ahead and see what that graph looks like if you want to. All right, let's take a look at example 1, where we give you an equation in standard form. It says, sketch the circle described below, x plus 7 in parentheses squared plus y minus 3 in parentheses squared equals 9. Now I want to point out quickly that you should be able to always recognize that this is a circle because it is in standard form. But later on today in this video, we'll see that sometimes people have chosen to actually FOIL out and distribute the terms, making an expanded or general form. So we still will be expecting you to know that this is a circle. So the 2 ways that you can kind of tell that this is a circle, besides it being in standard form, are that both x and y are squared, they have the same leading coefficients, and they're being added together. We'll talk more about that in the future. Okay, so taking a look at this standard form of a circle, notice x and y are both squared. We can also tell what our center is directly. See if you can write it down. What is your center hk? That's right, -7, +3. Good job. What is your radius? Well, that's right. If your radius squared is 9, r must be 3. Now with that information, could you draw yourself a basic sketch of a circle? Sure. Now when you're using the technology for your homework, be sure that you pick the circle function and designate 4 points on the circle. Let me show you what I mean by that. You would go 7 to the left, 1, 2, 3, 4, 5, 6, 7. There's 7 to the left and up 3, 1, 2, 3. So this would be the point from which all other points have to be 3 units away. 4 easy points that we could get would be 3 units above it, so 1, 2, and 3. 3 units to the right, 1, 2, 3, and 3 units below, 1, 2, 3, 3 units left, 1, 2, 3. Once you have 4 easy points on your circle, you can easily, hopefully, connect those in a circular manner. It doesn't have to be perfect for a sketch. Now, if you wanted to do it perfectly, of course, you can invest in a compass and a protractor and draw a much better picture than I just did. Okay. Definitionally, though, what is a circle? It's the set of all points which are the same exact distance from a fixed point. Oftentimes when there's a crime committed or something like this, you'll hear on a television show, for example, they'll say form a perimeter around where we think the crime happened. That idea is forming a circle typically that is the same distance away from the epicenter of where things happened. Okay, so that's what we mean by a circle, the same distance in all directions from that point. Okay, with that information in mind, let's check out a more complicated version of circles. Suppose we were given an equation like y equals plus or minus the square root of 3 minus x squared. When you get into your calculus and your higher level math classes, this is usually the form of circles that you'll be given. Now the reason for that is we've solved for y, okay? And think about why would I ever want to solve for y? Well, oftentimes when you're using technology, or if you're talking about doing certain calculus operations, we talk about functions where we've solved for y in terms of x, y depending on x. And by doing that, you could then fit this into like a TI 83 or 84 calculator as y1 being the positive and y2 being the negative. For example, if you went into a graphing calculator, you could let y1 be positive square root 3 minus x squared, while you could let y2 be negative square root of 3 minus x squared. Now, when you put those together, it turns out you'll get something like this, where you'll have a positive and then a negative semicircle. And put together, now you've graphed a circle, okay? So you're basically fooling your technology, which can't graph non-functions. But how would you have recognized this as such? Well, the pattern will always be y or y plus or minus a number on one side, a positive and negative square root on the other side, and then a number minus x squared. And that's what we have here. In fact, if I wanted to verify it, I could square both sides. Let's take a look. If you squared both sides, wouldn't you get that y squared equals a positive and a negative squared is just positive, and squaring the square root lifts the radical, so you just have 3 minus x squared. That's almost in standard form. Just scoot the x squared over by adding it to both sides, and you'll get x squared plus y squared equals 3. And that is, in fact, a circle whose center is at 0, 0, and whose radius is the square root of 3, because that's r squared at 3. So we could graph our circle that way. We could recognize it in standard form. Now, one of the other ways that we can see a circle, when it's not quite in standard form yet, is when every term has been expanded out, has been FOILed and distributed. In that case, we call this general form. And the way that we go about rewriting it into standard form is by completing the square. And I've given you a link to another website and video that'll help you complete the square in your notes. So feel free to go through that if you need a step-by-step explanation of completing the square. So if you do remember how to complete the square with me, remember what we did? That's right, we grouped our variables which were the same together. So for example, x squared plus 6x, and then we left some space to complete that square. And then we grouped our other types of variables, the y types of variables. Let's grab another color here. How about white? So that would be like y squared, it's positive y squared, and like negative 8y, and leave some space to complete that square. Now, if you had a constant, we would also kick it over to the other side by subtracting or adding it, doing the opposite of its operation. But in this case, there is no constant, there's just a 0 on the right. Now, do you remember the procedure for completing the square when you had x squared plus some bx, and you're looking for this magical third term, which makes this factorable very nicely? That's right, we take half of b and we square it. That's the number that we would usually add to both sides. So here b is 6 for the first trinomial that we're trying to complete the square on, and half of 6 is 3, and 3 squared is 9. So if I were to add 9 to the left, I'd have to also add 9 to the right. Good job. Similarly, to complete the square for this trinomial, the y-types, we take half of -8, which is -4, and we square it to get +16, and we add that to both sides. Now let's take a look at what we have. On the right side, 9 and 16 is simply 25. You're welcome, I gave you nice numbers, okay? On the left side, x squared plus 6x plus 9 can now be factored into something times itself. In fact, anytime you complete the square, you should get something times itself. You've created what we call a perfect square trinomial, or PST. And that's what we have here. What does this factor into? That's right, x plus 3 times x plus 3. And another way of saying that is simply x plus 3 to the second power. We're looking closer and closer like standard form. What about the next trinomial? What do we really have here when we factor this trinomial? Do you see it? Yeah, y minus 4 squared. So I add parentheses, y minus 4, close parentheses, to the second power. We would say right now that we have rewritten the original general form of a circle into the standard form of a circle. So now that it's in standard form, I could then continue graphing, and I've linked you to those Desmos graphs, so feel free to check on those after you try them yourself. The center here would be -3, 4, and the radius would be a 5. Okay. One more thing I wanted to point out to you. Just by looking at the general form, we could tell this was a circle because both x and y were being squared. In our next video, we'll be talking about when only one of them is squared. In that case, it will turn out to be a parabola. But when both of them are squared, the coefficients are the same, and they're being added together, this is a circle. Okay, let's continue practicing these skills of finding equations of circles. Example 2, sketch the circle described below. Now this is just like one we did on the last slide, so feel free to pause this video and try it on your own. Okay, so at this point, the first thing I would want to warn you about is that if you're trying to get rid of the square root, if you tried this already on your own, maybe you got stuck here, what you'd want to do first is isolate that square root. So you would need to add 2 to the other side. Add it to both sides, actually, creating y plus 2 equals plus or minus the square root of 36 minus x squared. Now that you have the square root part by itself, what do you think we're going to do? That's right, we need to square both sides. Squaring a square root, of course, will lift the radical, leaving you with whatever's underneath it. Now I just have parentheses y plus 2 getting squared. A positive or a negative squared is irrelevant. They're both going to turn out positive. And lifting a square root would just give me 36 minus x squared. Is that in standard form for a circle? You can look back at your notes. Not quite. What should I do? That's right. I need to move x squared to the left side by adding it to both sides. Now I have x squared plus parentheses y plus 2 quantity squared equals 36. This is now in standard form. If you want to be super specific, you are welcome to write parentheses x minus 0, close parentheses, to the second power. If you really want to tell the reader 0 is my h, that's perfectly fine. So your center is at 0, -2. Make sure you watch your signs. You can go back to that first slide if you need to remember what the form was. And the radius was the square root of 36, which is 6. Good job. Now to plot this circle is not difficult. You can take your time, pause the video, and do it yourself. You'd go to 0, -2 as your center, and then 6 units in each direction. 1, 2, 3, 4, 5, 6. So I have a point at 6, -2. 6 above, 1, 2, 3, 4, 5, 6. So that's at 0, 4. And then 6 to the left, 1, 2, 3, 4, 5, 6. That would be at -6, -2. And finally, 6 below the center, 1, 2, 3, 4, 5, and 6. So that's at 0, -8. Now that you have 4 points on the circle, connect those dots in a circular manner. Again, mine's not going to be perfect. Sorry about that. Unless I have my compass out and my protractor, then it would be perfect. Okay, so something like that. Mine's a little degenerate, but something like that. Okay. The idea again is you first need it in standard form, then you need to plot your center and your radius correctly, get 4 points in each direction from the center, draw a sketch. Again, we haven't really used the equations yet. We've just been practicing getting them and graphing them. Okay, so you will get some further practice in the homework where you get to apply this a little bit more. All right, I think we have one more example left, and it's like the other one we did on the previous slide, so feel free to pause it and try it yourself. Example 3 says, could you rewrite this circle described below in standard form? So again, if I was not telling you it was a circle, how would you know it's a circle? Yep, they're being added together, they're both squared, and they both have the same coefficients. So those are our 3 clues that this is a circle, if they hadn't told you that, okay? So how would you go about this? Well, that's right, we need to complete the square. So what did we do with that? We grouped the variables together, good job. So if I group my x variables together, I would have x squared minus 4x, and I'll leave some space for my completion. And then I would group my y variables together. So positive y squared, good job, minus 2y, and then leave some space for completing that square. And what about your constants? Good, yeah, we need to move them over to the right side. So moving -4 to the right side, you'll have 0 plus 4, which is just a 4. Yep, that's it. Now let's complete this square here by remembering to take half of b and square it and add it to both sides. Half of -4 is -2. Squaring -2 is +4. So if I add a 4 to the left, I must add a 4 to the right. What about the next one? Yep, half of -2 is -1, and -1 squared is +1. Should add 1 there. So if you add a 1 on the left, you'll also add a 1 on the right. Very good. Can you go ahead and take a moment, if you haven't already done so, pause the video and write your circle in standard form? Let's see what you did. Did you get x minus 2 in parentheses squared plus y minus 1 in parentheses squared equals 9? I hope so. If you did, there is your circle in standard form. One way that you could check that with technology would be to graph them both side by side in Desmos.com and see that you get the same circle, right? In fact, if you wanted to check, the center here should be at 2, 1, and its radius should be at 3 units in each direction. Okay, but the actual equation is the first box there. All right. Well, at this point, we've done a lot of practicing of how to get the equation of a circle and practice graphing it. Next time, we'll be talking about parabolas, so make sure you're an expert at circles before I see you next time. All right, you know the drill. Happy practicing, because math is not a spectator sport.